Okay, good morning, class. We are in Module 4, and today we're going to be working on Lesson 11. So our objective today, we're going to demonstrate the possible whole number side lengths of rectangles with areas of 24, 36, 48, and 72. Now, I know that seems like a lot of numbers, but today we're going to focus on 24 and 36. I know that having a double digit in the area model is new to you, so I want you guys to be comfortable with working with these two numbers, and we're going to be using the associative property. Now, I know that's probably a newer concept to you, but we're going to touch on that a little bit today. So, to restate our objective is I can demonstrate the possible whole number side lengths of rectangles with areas of 24 and 36. Like I said, today we're going to do 24 and 36. So what I want you guys to see and through this lesson is that you can be given an area, but you can show it in multiple ways. So if you have 24 square units, you can use multiple ways to show that. There's not just one way or one number sentence or one equation that can demonstrate that, but there are multiple ways that you can break it down to see that. And that's what we're going to do today. And I want you guys to get some hands-on practice so you can actually visually see it. So to start, we're going to do some group counting, some fluency practice. So I know you've done this with Miss Davis, and I know you've done it in the classroom, on your Zoom meetings. So today we're going to count forward and backward, and I'm going to point, but really what I'm going to do is we're going to do 6s, 7s, 8s, and 9s today to 60, 70, 80, and 90, but I'm going to give you a visual. So while you're at your seat, you can either listen, say them in your head, you can just listen to me, or you can whisper them, because I know you're around everybody else and there's different things going on in the classroom. So today we're going to start with our 6s. So everybody with me, 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Okay, now we're going to go to our 7s to 70. So 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. So now 8s to 80. 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. Now we're going to do 9 to 90. 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. Okay, so this is what you've been doing. You've been working with the distributed property to find the area of a rectangle. So here's our area model right here. We have a side of 3, and then we have the width, which is 5. We have it broken down into 5 and 3. So we've drawn our line here, and one is shaded and one is unshaded, as you can see. So you can write this down and draw out your shaded and unshaded portion. So we're going to write an equation or number sentence to find the area of the shaded rectangle. So how would you do that? So you're going to say, Miss Foster, well, how am I going to break this up? How am I going to find the area of the shaded and then the unshaded? So many of you are going to say, well, first what I'm going to do is I'm going to do 3 times 5. So right here, we're going to do 3 times 5 because that's going to give us the area of that shaded portion. So now we're going to write an equation of the unshaded rectangle, which is this right here. So that would be our 3 and our length of 3, which would be 3 times 3. So how can we use this equation or number sentence to find the area of the big triangle? So the entire area of this area model right here, this rectangle. So what we're going to do is we're going to take our two equations for our shaded and unshaded portion. So we have 3 times 5 plus 3 times 3. So we know that 3 times 5 equals 15. We're going to bring down our plus sign, and then 3 times 3 is 9. So now we need to find the sum of 15 plus 9. And the sum is 24. So we now know that the area of this triangle right here is 24 square units. Okay, so at this time, what I want you to do, and obviously we know I'm actually going to go back, because if you see here, what is 5 plus 3? Well, 5 plus 3 is 8. So what we did is we just broke this down into 2 smaller parts. Instead of having the larger number 8, we just broke it down to make it a little bit easier to find the square units. So what I'm going to have you do now, here is our 3 by 8 rectangle, which we know we just found equals 24 square units. So I want you to find as many different combinations as you can using your tiles to make a 3 by 8 triangle that equals 24 square units. So I'm going to pause the video, I'm going to give you some time, I'm going to give you 5 minutes, and I want you to work with this and see what you can find. See what different combinations you're able to come up with. Okay, so I hope most of you were able to find some different combinations of how you could make 24 square units with your tiles. Okay, so now we're going to move on. So we still have our 3 by 12 now area model. So we're finding sides. So we're basically finding the unknown sides. So we're going to take 3 by 12. Since you were just introduced to double digits, let's break down 3 by 12 into smaller numbers, just like we did with our previous model. So one equation we can do is 3 times 2 times 6. And you're like, well, Miss Foster, where did you get that 2 and 6 from? Well, the reason why I did 2 and 6 is because I broke down the number 12 into 2 times 6, because we know that 2 times 6 equals 12. It will give me 12. So all I did is I just took the 12 and I broke it down into smaller units to make it a little bit more understandable. And some of you might be able to, when you look at that, when it's broken down, you might be able to see and build that concept in a better way, because that makes more sense to you than it does to have a big number like big 12 up here. So we're building blocks here. We're building up to getting to be able to just use 12 instead of having to break it down. So we can find different side lengths by adding parentheses to create a new equation or word sentence. So we can take this same equation right here and we can break it down and put parentheses and change that equation, and guess what? We're still going to end up with the same area. So we're going to take the equation 3 times 2 times 6. And what we're going to do is we're going to put some parentheses right here around our 3 and our 2. So what does that do to our equation now? Well, that gives us 6. Where'd you get that 6 from? Well, 3 times 2 is 6. So we bring our 6 down here. Now, what do we have left? We have a 6. So there we go. We're going to bring our 6 down. And what does 6 times 6 equal? Well, it equals 36. So right now, I want you to think of other ways and other equations or number sentences that are going to equal 36. We have multiple. So we now know, oops, let me go back. Sorry, guys. We now know that we have 6 and 6 for our 2 possible side lengths of the rectangle. So we have found of the whole number side lengths for the rectangle that has 36 square units. So we didn't get to go through them all today, but we did do 3 and 12 and 6 and 6. So if I do this, and I go to my whiteboard, if I take my area model, and I keep 3 here, and remember how we had 12 up here? Well, what we can do, because we have 6 and 6, we now know we can break that up into smaller units to make more sense. But we still know that this here equals 12. So, when you continue to work with your tiles, you'll be able to see that when you can take a different assortment of tiles, different numbers of tiles, to make that square area equal 36 or 24 like we did previously. And I want you to think back to your prior lesson, lesson 10, where you used the distributive property and you were finding the basic area of that area model. So basically what you need to understand is that I can give you an area and you can express that in multiple ways. So just because you have an area of 24, it doesn't mean that you have to have 2 very specific numbers to find that area. There's not one way. I want you to understand that you can manipulate your tiles to find different ways like we did in our practice. And hopefully that'll help you make more sense of what we're talking about finding multiple ways to find the whole number side lengths for the rectangle. Of 36, of 24, even when we go up to 48 and 72, the same concept still applies. I hope you guys learned a lot today. If you have any questions, Miss LeBeau is there to help you out today. You can still ask Miss Davis to clarify anything that you didn't understand from this lesson. And I hope you find it useful when you do your problem set on Seesaw. Have a wonderful day, everybody. Bye.